Build a simple LED flasher circuit using a 555 timer IC on breadboard. You can also adjust the flashing rate of the LED by adjusting the potentiometer over here. Let's test it. These are the components required to build this project. I'm going to use a breadboard, some jumper wires, 100 microfarad capacitor. You can also use different values, 330 ohm resistor, LED, 555 timer IC, 1 kilo ohm resistor, a potentiometer, and I'm going to power the circuit with 9 volts. So let's get started. Let's begin the project by inserting the 555 timer IC to the breadboard. And as you can see, there is a notch right over here. Whenever you see it, then the first pin below this notch is going to be the first pin. Then we have pin 2, 3, 4. Up over here we have pin 5, 6, 7, and 8. So what I'm gonna do is that I'm gonna connect the first pin of the IC to ground. And I'm gonna connect pin 4 and pin 8 of the IC to the positive rail of the breadboard. Next, I'm going to connect pin 2 and pin 6 of the 555 timer IC to each other. And I'm going to grab my 100 microfarad capacitor. As you can see, the longer pin is going to be anode and the shorter one is going to be cathode. So I'm going to connect the anode of the LED to the second pin of the IC and cathode to ground. As I've said earlier, you can use different values. After we build the project, I'm going to show you how different capacitor values can affect our flashing rate. Now let's grab another jumper wire and let's extend the 7th pin of the IC. Let's connect our potentiometer. I'm going to connect the VCC pin of the potentiometer to pin 7 of the IC. And let's connect the middle pin of the potentiometer to the second pin of the 555 timer IC. Here is my 1 kilo ohm resistor and I'm going to connect it to the pin 7 of the IC and to the positive rail of the breadboard. Let's grab another jumper wire and let's extend the 3rd pin of the IC over here. The third pin of the IC represents our output pin, and therefore we are going to connect our LEDs across it. So where's my LED? I'm going to connect the anode of the LED to the output pin of the IC, and I'm going to limit the current across the LED using 330 ohm resistor. So one end of the resistor is going to be connected to the cathode pin of the LED, and the other end is going to be connected to ground. We are pretty much done with the setup of the circuit, and before I connect the power supply to the breadboard, let's have a look at the rails of the breadboard. So on the upper side, we have wire connections only on positive terminal of the breadboard. But on the lower side, we have wire connections on the ground as well as the power terminal. So best thing to do is to connect the power rails of the breadboard to each other, and that's it, problem is solved. In this case, current is going to be flowing from both rails of the breadboard, and there is no need for connection on the ground terminal since there is no wire connections on the upper side of the breadboard at all. Let's connect our power supply to the circuit. I have 9 volts coming in, and as you can see, our LED flashing circuit works perfectly. So let's play with this circuit for a while. I'm gonna start with the potentiometer. The potentiometer will determine the charging and discharging rate of the capacitor over here, and it can control the flashing rate of the LED. So let's change the resistivity of the potentiometer and let's see what would happen. So as you can see, the LED flashing rate is going to be increased, and now it's at its maximum. And whenever I turn the potentiometer in the other side, the flashing rate would be decreased. So let's see. Yep, perfect. Now let's play with our capacitor. So I'm gonna bring the potentiometer back to its first place. So our capacitor along with the resistors, they determine the frequency of the output square wave. As the capacitor charges and discharges, it changes the timing of the output signal, affecting the flashing rate of the LED. So in our project, we used 100 microfarad capacitor. Let's disconnect the power supply, disconnect the capacitor, and let's grab another capacitor value. I have 4.7 microfarad capacitor over here, and let's see how the circuit would react to this capacitor. So as you can see, a smaller capacitor will result in shorter charging and discharging times, resulting in a faster flashing rate. So let's do the opposite. Let us grab our, let's see, I have, yeah, that's going to be big one, 470 microfarad capacitor. And now the flashing rate must be way too smaller than before. So as you can see, it takes approximately 2 or 3 seconds for the LED to turn on and turn off. Let us disconnect the capacitor and let's grab 1000 microfarad capacitor and let's see how would it look like. So here's my 1000 microfarad capacitor. And as you can see, the flashing rate would be in 6 or 7 seconds. That was the whole idea with LED flasher circuit. If you guys enjoyed my video, please give me a like and do not forget to hit the subscribe button. Thanks and have a good day.